Welcome back to the reaction zone, where chemistry is made as simple as possible. Today we're going to look at one of the classic gas laws in chemistry, Boyle's Law. What does it say? Why does it matter? And how does it show in real life? Join me as we explain this. Boyle's Law shows the relationship that exists between the pressure and the volume of a gas. It states that the pressure of a gas is inversely proportional to its volume, provided that temperature and amount of gas remain constant. Mathematically, this is represented as P is inversely proportional to V. P here stands for pressure, V stands for volume. When the proportionality sign is changed on the quantity sign, the mathematical expression becomes P is equal to K over V, where K is the constant of proportionality. And when you make K the subject, PV is equal to K. Under initial and final conditions, this equation here becomes P1 V1 is equal to P2 V2, where P1 and V1 represent the initial conditions of pressure and volume of the gas, and P2 and V2 represent the final conditions of pressure and volume of the gas. The first graph that we have here shows a plot of pressure against volume. Now, if you look at this graph, it is very clear that as the values of pressure increases, the values of volume decrease. So this clearly shows that when pressure goes up, volume comes down. And when volume increases, pressure decreases. The second graph that is here shows a plot of pressure against the reciprocal of volume. The reciprocal of volume is represented by 1 over V. And we can see that this graph gives us a straight line. What this means is that as pressure of the gas increases, the values of the reciprocal of volume will also increase. Also, if the values of pressure decrease, the values of reciprocal of volume will also decrease. Having said this, Boyle's law is seen in action when a balloon is squeezed, or when gas is compressed in a sealed cylinder. This is because when either of these two situations occur, the gas molecules are restricted to a narrow space, and as a result of this, they will collide more with the walls of the container, thereby increasing pressure. We're going to look at two real-world or two real-life applications of Boyle's law. The first one is in the use of medical syringes. And the second one is in breathing. Medical syringes work with Boyle's law. When the plunger of a medical syringe is pulled back, the volume increases and the pressure decreases, and this enables fluid to be drawn into the syringe. With respect to breathing, our lungs obey Boyle's law. When we inhale air, the chest expands, the volume increases, pressure decreases, and air is drawn in. This is the basics of Boyle's law, which I believe with this explanation has been simplified as much as possible. For more videos on chemistry, where important concepts are demystified and broken down, kindly hit the like button and hit the notification bell in order to be notified when new and updated videos drop. One gas law is down, more to go. Kindly subscribe to our channel. See you some other time.